Hello everyone and welcome to the webinar, Extending Imagery to the Cloud with Infinitely Scalable Raster Analytics. This is the second webinar in our series all about modernizing national government with GIS. Before we begin, I would like to introduce our speakers for the day. First is Kurt Schwope, the Imagery Industry Lead for Esri. With 30 years of experience with remote sensing technologies, he continues to be on the forefront in introducing image processing technology and applications. Kurt will describe the advancements in the ArcGIS imagery platform and how raster analytics in the cloud can significantly improve your organization's productivity. Mark Ramiro is a solutions engineer on the imagery team. With 11 years of imaging experience, Mark is heavily involved with imagery product quality assurance, driving requirements, and developing imagery solutions customers. Mark will be demonstrating the rich imagery capabilities of ArcGIS 10.5 and Pro version 1.4. My name is Kathleen Ojo. I am a specialist on the industry marketing team, and I'll be your host for today's webinar. Before we begin today's presentations, I'd like to cover a few administrative items. First of all, this webinar is being recorded. An email link to the recording will be sent out to all attendees at the conclusion of the webinar. Second, we are reserving time at the end to answer a few of the questions you may have. Please type your question into the question dialog box on the webinar screen. We will try to answer as many questions as we can. Answers to any questions we miss will be sent out via email. Finally, at the end of each presentation, we're going to ask a polling question. These polls will help us better understand your interests and intentions about your use of drones. Use the webinar polling tab to respond to the poll. Here is our agenda for today's webinar. Kurt and Mark have prepared a mix of PowerPoint presentations and actual live product demos to showcase the advanced imagery capabilities of ArcGIS. The focus is on introducing and demonstrating the ArcGIS imagery platform, explaining how it achieves infinite scalability, and showing a variety of applications that have been built based upon these capabilities. As they go through the presentations, don't forget to type any questions which we'll try to answer at the end of the presentation. So with that, we are going to launch our first polling question. Give me 1 second. Which imagery-derived products are the most important to your organization? You can select any that apply. We'll give it a few seconds here for everybody to respond. Looks like responses are still rolling in. Thank you everybody for participating. All right, looks like everybody's had a chance to weigh in. I'm going to go ahead and close the poll now. And on your screen there, you can see the results. Sorry, there you go. So it looks like we have a pretty wide variety of products that you find important to your organization, weighed a little bit heavily towards accurate imagery base maps and feature data. All right, thank you very much everybody for participating in our first poll. We'll have a couple more coming at you as the webinar progresses. And now I'd like to hand it over to Kurt Schwope to start the webinar.
Thank you, Kathleen, and thank you everybody for responding to that poll. That kind of helps guide the way I'd like for the presentation to go today based on everybody's input with that poll. When you think about ArcGIS and the imagery platform, I want you to think big enough to support nationwide imagery programs. But I also want you to think small, but in great detail, like the super high resolution imagery that you can get from drones. And finally, I want you to think 3D, because the world is multidimensional, and ArcGIS can support a multidimensional world. Consider our imagery capabilities as an overlay that works seamlessly with the entire ArcGIS platform. The server tier provides the foundation for imagery management. It ingests, catalogs, and produces the dynamic imagery services used by the other components on the platform, and provides the authoritative source data as a system of record. The processing tier provides rich analytics needed to transform raw sources of imagery into the various information products needed for understanding and decision-making. In this regard, the processing tier provides a system of insight. The final tier is a system of engagement that allows imagery services and derived products to be consumed by a variety of applications running on any device in anywhere. Altogether, these three components allow you to see the Earth, find the patterns, and share that information with others. This imagery technology is an integrated part of a spatial data infrastructure, or SDI. Its role is to be a source of geospatial information for GIS. Most image processing tools are designed to either make imagery geospatially accurate, produce elevation, or extract 2D or 3D information to populate GIS feature layers. As this diagram points out, geospatially correcting imagery is a typical first step before authoritative data can be generated. Through geoprocessing and specially designed image analysis tools, more automated analytical processes are used to extract information layers to produce derived products from the imagery. Finally, GIS and imagery-derived products are combined to produce the up-to-date information layers needed by planners and decision makers. From the spatial data infrastructure, four patterns emerge. The first being traditional imagery analysis and basic exploitation, typically done on a desktop. The second is robust imagery management to work with massive archives of imagery and point clouds, that it's constantly being updated with new sources of information. The third is rigorous photogrammetric processing for precise geospatial accuracy in the extraction of 3D elevation data from stereo. Finally, there is raster analytics, which is the primary topic of today's webinar. This is the technology that extracts features from imagery for use within the SDI. Esri is in the process of developing specific bundles for each of these implementation patterns. These bundles will be available later in the year. The power of the ArcGIS imagery platform has been significantly increased with version 10.5. The image server capability has been physically separated from the enterprise server. This allows independent scalability between user demand and image processing requirements. If user demand is greater than processing need, scale up the enterprise server without adding more image servers. On the contrary, as the processing workload increases, more image servers can be added to handle the load. Within cloud environments, Esri has simplified this deployability so that processing can easily be scaled to meet production demands. The power of this deployability is further enhanced with our new raster analytics distributed processing approach. Typical algorithms leverage multi-threaded processing as part of the operating system. A specific process can only scale to the number of cores available. With distributed processing, an individual processor algorithm can be spread across multiple CPUs with multiple cores. In cloud environments with unlimited virtual machines, the result is infinite scalability. If a specific task takes 100 hours to process on a single CPU, then spin up 100 CPUs and get the work done in an hour. This is the power of Esri's new image server with raster analytics. The cornerstone for successfully deploying high-end raster analytics is imagery management. ArcGIS uses a powerful imagery information model called the Mosaic dataset that allows the image server to manage millions of imagery files. It is a virtual container used to hold all the key metadata for each imagery, so it can be quickly queried for data retrieval and on-the-fly processing. It maintains the orientation of each image for reprojection. It stores imagery statistics for dynamic range adjustment, and most importantly, it works without any reformatting of the original source data. This means that thousands of images can be rapidly added to the archive and be immediately available as a web service. The Mosaic dataset can also ingest multiple sources of imagery files. This includes images taken from aircraft, satellites, or even drones. It works with multiple modalities of imagery to include EO, RGB, multispectral, and radar. Besides imagery, the Mosaic dataset works with elevation data, LiDAR point clouds, and other raster map products, and it is fully certified for NITF. Another key capability of Mosaic datasets is the ability to add raster processing functions as part of the imagery archive. This allows function to the imagery as it is requested from the server. For instance, an archive may only contain one elevation source, but it can have multiple functions assigned to it. To dynamically display that elevation data, perhaps as a shaded relief, or dynamically create a tinted relief, or click one that shows aspect and another that shows slope. The user simply zooms into their area of interest and selects how they want the elevation to appear, and the server applies the appropriate function as the image is being displayed. The processing is very fast as the server only applies the selected function to the pixels being served and not the entire image archive. Raster functions as part of the Mosaic dataset are ideal for basic image processing tasks such as pan sharpening, calculating band ratios, and automatically improving the overall appearance of the imagery. But for more advanced image processing requirements, ArcGIS provides a suite of more powerful algorithms that are enabled by the new 10.5 distributed processing capabilities. Things like change detection, image classification, and elevation extraction from stereo fall into this category. In fact, most raster processing GP tools can be run as part of raster analytics. Perhaps the most important of these new raster analytic tools is object-oriented imagery classification. Significant improvements in 10.5 and Pro 1.4 have made this tool more versatile. Selecting signatures has been made easier. A new random trees classifier has been added, and the algorithms have been enhanced for distributed processing. A key lighthouse account for our new classification tools is the Chesapeake Conservancy. They built a powerful geoprocessing model designed to automatically extract land cover from 4-band NAIP aerial imagery. This process allows users to train the extraction process to identify specific types of land cover and then search through the entire archive for similar types of features. Earlier this year, Esri helped Chesapeake migrate this extraction workflow to the Azure cloud, and the results were outstanding. Processing that normally took hours were shortened to a few minutes. Using this approach, Chesapeake Conservancy has been able to improve the National Land Cover Database for the entire Chesapeake Bay watershed. Here you can see the NLCD at 30-meter resolution, but they enhanced it so now it has a 1-meter resolution. Now they have a working data set to help them with their precision conservation efforts to stop nutrient runoff from agricultural fields within the watershed. It is this excessive fertilizer that leads to massive algae blooms that rob oxygen from the bay by choking out crabs, clams, and other game fish. A simple 20-foot forested buffer between the field and the tributary can stop this runoff. With this high-resolution land cover, Chesapeake Conservancy can now readily find the gaps within that buffer zone. So whether it be land cover, weather, or solar suitability, the new 10.5 image server with raster analytics has the power to take large projects requiring massive amounts of imagery data and reduce the processing time to workable levels. Doing a comprehensive demo of all this functionality is beyond the scope of this 1-hour webinar, but Mark Romero will now demonstrate the important fundamentals of these new 10.5 capabilities. So now I'm going to turn it over to my colleague, Mark Romero.
Okay, thanks. And Kurt, can you see my screen okay?
I can. Looks great.
Okay. Thank you, everyone. And so what I'm going to do is jump right into where Kurt finished off talking about the Chesapeake Conservancy. And so the area of interest that I'm showing here on my screen is the area of interest of the Chesapeake Bay watershed. And so the data here is courtesy of Chesapeake Conservancy. And so Kurt talked about the workflow in how they're using ArcGIS tools to generate this 1 meter land cover, which you're seeing on the screen. And so as I zoom in to show you the resolution, you can see the level of detail at which the Chesapeake Conservancy generated this product. And so this is 900 times the amount of data as the National Land Cover data set. And if we compare the product against the World Imagery Base Map, I'll zoom in a little closer. You can see how accurate the product is, and what Chesapeake Conservancy has been able to obtain is 90% accuracy across the entire area of interest. So quite a bit of data at a very fine level of detail. And if I go ahead and compare that to the National Land Cover data set, you can see we've gone from this to what is previously available with the National Land Cover data set with a resolution of this. So quite a drastic improvement in the level of detail that Chesapeake Conservancy has been able to obtain. So what I wanted to do is show how you can use image processing in ArcGIS to be able to obtain a similar product. And so I've zoomed into a particular area of interest. This is in Delaware, and wanted to highlight how you get started with this. And so the heart of image processing within ArcGIS is our image processing tools. And so these are easily accessible in a window here. We call these raster functions, which Kurt talked about. And as I zoom down or scroll down through the different image processing tools, you can see we've got quite a bit. They are categorized by the type of image processing that you might do. And so as you go down and want to run one of these tools, you simply select the image in your table of contents, click the tool that you want to run. In this case, I'm just going to run a simple NDVI. Adjust the parameters, and then click the button. And that executes immediately. It generates the product and puts it right into the map. So I'm going to go ahead and remove that. So that's a very simple example. Now, what if you wanted to run a slightly more complex one? Well, you can take these results, or you can take your what we call functions or image processing tools, and you can save them, or you can actually edit them and generate your own custom image processing tools. So in this case, I'm just showing an example of one that Chesapeake Conservancy created for creating an NIR chromaticity. And so we've ran that, we've saved it, and then that becomes now part of your project. And so you can take these and apply them directly to your own imagery, or you can share these directly out. And so if I wanted to run a different one, in this case this is a custom vegetation index that the Chesapeake Conservancy created specifically for this project, I can run that directly on the image, and you can see the band indice and the method that they used, and I can run that directly onto the image. And so now, as I list the different custom image processing functions that we've created for this project, at any point we can just generate these products by running these tools. And so just to kind of step through the different products that we've created here, I just showed the vegetation index. We've also generated one with a brightness index, one with a chromaticity index, and then finally that one with the vegetation index. We can then take these and combine these different function chains to get to that final step. So let's look at the full process and what that looks like. So here are the first sets of indices that we've just generated. Here's the vegetation, the brightness index, and then the band arithmetic. We've then taken those, run a composite, then we've segmented the composite, and then finally we've classified that. And so again, we can take the image that we want to run through the full process and then apply that directly onto the image that we're interested in. And now here's our fully classified image. So for this demo, I've just been running this on local data. But what if you wanted to utilize raster analytics and run this against a bigger area of interest? So what we've done is we've taken the inputs, which in this case is a set of NAEP data, and we've clipped out the entire state of Delaware. And so if I wanted to run this entire process against this, it's the same step. I simply go to the raster function chain, click the one I'm interested in, I'll apply that directly to the image. But instead of creating an output that displays on the fly in my table of contents, we have a new option here under the raster functions chain that lets you select something called the web imagery layer. And this will persist or write out the output to your portal. And so as I hit next, give it a name and some tags, and hit run, that'll begin the process of generating those products on the portal server. And when they're done, they'll be listed in your My Content and available for you to use. And so what we're throwing at this is probably 10 different Azure instances with 20 cores apiece that let us apply these same sort of raster functions into the cloud. So we're going to let this run, and as I do that.
So Mark, you're running this against 200 cores, basically?
Yeah, so nine machines, 20 cores apiece.
Okay, so
we're going to let that run for the entire state of Delaware here.
And that's 1 meter NAEP data?
Yes, and so on my testing, this should probably take about 15 or 20 minutes. So hopefully this will be done by the time we're done with the presentation.
Sounds good.
All right. So I'm going to go ahead and turn this back over to you, Kurt.
Okay. Well, should I talk slowly, Mark? So no, we'll let those 180 cores run while I change presenters and switch it over so you can see my screen. Okay, and let me back up here a little bit, because what I want to do is have a polling question. So it's time for polling question number 2. And Kathleen, if I could get your help to go ahead and start the poll. The question is, how committed is your organization to the cloud? Answer A is cannot use the cloud. B, able to use private secure cloud versus a public one like Amazon or Azure. C, I've just started to investigate the use of the cloud, but no implementations yet. D, have started using the cloud, but our work is limited. Or E, our organization has fully embraced the cloud. So go ahead, and if you can respond to the poll. Yeah, it's a good mix. Last few votes are coming in. Well, that's interesting. It looks like that the majority of our audience is definitely starting to look towards some type of cloud processing, and I guess that makes sense. Otherwise, you probably wouldn't have been on today's webinar. But I am very pleased that 30% of you have started to use the cloud, and even though your applications are limited, it's starting to grow. And our role here is to help you continue in that direction, to start working some of these geospatial applications and leverage that distributed processing that Mark was showing in his demonstration. So let's move on into just a little bit of a different category of leveraging the cloud, and that focuses on sharing and collaboration with apps. Esri has made a significant investment over the past few years to develop server technology that supports apps that can run on any device and anywhere. And the raster imagery team has done the same and supported that effort. We've introduced a number of new capabilities that can be used inside of apps that you can build and deploy across your enterprise. And so it's very exciting because, the information products you're creating don't do any good sitting on your server. They're much better if they're brought out and used by people across your organization. The other thing that we've done is ensured that some of the power that you saw in Mark's presentation is available via these apps. And we're going to show you some demonstrations of how you can set those up and what you can do with those apps that can be done. We encourage you to take a very close look at the Web App Builder. It's available either on your portal or as part of ArcGIS Online. It's these tools that allow you to very simply go in, select application templates that are designed for various devices. Then you can identify the different services, whether it be imagery services or feature services, that you want to feed into this app. And then my favorite part is this extensive widget library, which are essentially the functions that you can drag and drop and place directly in the app that you want to run. Back at the ASPRS conference in March, we actually held an imagery appathon where we sat down with a group of folks, showed them all the various widgets, and let them go out and build the various apps that they could make using this particular approach. And the results were pretty amazing on the creativity on how people were able to take advantage of these new tools. One of the things I would like to point out, if you have been to the Web App Builder and looked at the widget library, you may not see the extensive amount of imagery widgets that we have available because we offer a number of others on the GitHub website. And if you're interested in that, just send myself or Mark an email and we'll show you how to go to the GitHub website and actually install those various imagery widgets directly into your Web App Builder so you can start taking advantage of the technology. But it's pretty exciting with what you can do with that, and Mark is in his next demonstration is going to show you some of those capabilities with the widgets. And what this allows you to do is actually take that platform model that I talked about at the beginning, where you kind of see the earth. In other words, you access the content, and of course you find the patterns with analytics, and then you share that out with those web apps to anybody who wants to access the data. And that, to us, is the paradigm on how we go forward with supporting the imagery across the enterprise. It doesn't take out the expert who has to use desktop products and other rich analytical capabilities to produce the various derived products that come from the imagery. But it does extend imagery beyond the expert and lets them be able to start using and manipulating all types of imagery for different types of information products that they need to make decisions on a regular basis. We'd also like to talk about how much work we've done recently with support of 3D information, specifically LiDAR and point clouds. This is a major initiative underway inside of Esri. The 3D GIS is definitely revolutionizing how we plan and design. It's a big part of where we're going. It starts with basic, raster analytics or point cloud analytics, where we can do things like imagery differencing, shaded relief, contours, different types of analysis to bring out that 3D information. And here, for those of you who've done change detection, you've probably heard the term red fled, blue new. Well, we apply the same thing to change detection using point cloud data and elevation. This imagery was actually collected with drones, and we compared it to an existing LiDAR data set that was provided by the Corps of Engineers. And we were able to do some differencing to show where shoals had been building up in this particular area of the Outer Banks. This one is near Wrightsville Beach, North Carolina. And you can see the blue areas where the shoals have been extended or the beach area has been extended, and red areas where the dunes have been worn down due to storms and other types of things. But that's the type of analysis that we can start doing with 3D data. Other things that we've been able to do is we've greatly improved our new point cloud classification techniques. So you can start off with a raw point cloud where none of the points are really classified, and start using some semi-autonomous tools to identify buildings and vegetation, even power lines and those types of things that you want to bring out into 3D. We've pushed that now to the point where we're even starting to do a very good job at extracting buildings to include roofs and roof lines. If you have some existing building footprints in as a GIS layer, that can even improve the results that you're getting. And so those are some very powerful functions, taking advantage of the rules-based extrusion capabilities that come through CityEngine. And then we've added a whole number of visualization capabilities in our new ArcGIS Earth and other scene layer packages that are available for various web apps. And Mark is going to show examples of these in his very next demo. So we're very excited. This is an extraction that we did from actual high resolution point cloud data from LiDAR data of an area near Miami, Florida. And you can see the level of detail that we were able to pull out in these buildings. The nice thing about this is that this is now a feature layer. And so because it's a feature layer, we can run GIS analytics against this, perhaps an inundation model, a land cover model, whatever it might be. And so this is a fundamental part of where we're going with our raster analytics to be able to do this type of extraction of 3D information. And then, of course, the key thing is visualization. And ArcGIS Earth is a wonderful new tool that you can freely use to upload all these different layers of information and visualize them, work with them, interact with them over the web. So, Mark, hopefully I stalled a little bit and let that raster analytics run a little bit. Are you ready for your next demo?
I'm ready.
Okay. Do you want me to change presenter, or can you do it?
I think I can do it here.
Okay.
Okay, and so what you're looking at is the brightness index function chain that I ran, and it just finished. You can see the succeeded notifier here. And then if we switch over to the web and log into our portal, under my content, we now have the new item here that we just ran here. And so there's the brightness one, and then also here's another one that I just added as well. So that happened in less time than I thought, so that's what happens when you throw that much data at it. Okay, so I'm going to switch back to
so going back to that, Mark, so basically what you did is you ran that analysis on the entire state of Delaware. You produced a web service out as an output, accessed it via your portal site, which is, for those of you who don't know, portal is ArcGIS Online behind the firewall, so it's protected and it's private for your enterprise. And then you made that available as a web service so anybody on the enterprise that's behind your firewall can access it.
Yep, that's exactly right. And so based on all three of those indices and the composite. This is the product that I just kicked off, and you can see that here. So
excellent.
All right. So I'm going to switch back to Pro, and I want to talk about a project or a workflow that that we have that's publicly available. And so one of the things that we have to do as part of the Living Atlas of the World is populate our base map content. And so what you're looking at here is the topographic base map. And so these are all the different base maps that are provided as part of ArcGIS Online. The one we're looking at here is this topo base map. And what I wanted to point out is the buildings here. And so oftentimes we get building footprints from customers or authoritative sources, but there are many areas that are part of the Living Atlas of the World, like here in Delaware, where we don't have any building footprints. And so where there's no footprints, we have to go out and look for different ways to generate these on our own. And so one workflow we are working on with the Chesapeake Conservancy is to be able to take their land cover data set that we've been talking about here and doing something or extracting out the impervious surfaces or the structure classification that they got. And you can see those are highlighted in red. And so these are very nice features, but as you zoom in, you start to see a little bit of pixelation, and this is just from you know, the resolution of the NAIP service. And so with the workflow,
in the trade they call that blobology, I think.
And so once we have these data sets, we can just run out of the box tools, and again, these are just raster functions that we've ran against the data. And so this is a raster function where we just simply do a remap of all the pixel values, and what we end up with is values of 1 that represent the buildings or the structures, and value of 0 that represent everything else. And then we just simply go through a set of tools. So in this case, we take those and then we perform a vectorization process. We just do a raster to polyline and isolate those different polygons. And then if we have parcels, property parcels, we can intersect those. And then I'm going to show you this model here. This may look pretty big. This is a pretty simple model that takes those footprints and simplifies the extent of them. And then what you end up with is something like this that we can now put into the topographic base map. So these are workflows that are publicly available that we've provided for any of our users to be able to perform this. Once we have these building footprints, we can then do some more interesting things. So we can then incorporate that into some other workflows. So in this case, we've got some LiDAR data in a county in Virginia, and we're able to take that LiDAR data in Pro, and using our new classification tools, we can classify the ground, the buildings, the vegetation, and other kinds of features that we're interested in. We can then merge that with the building footprints that we were able to generate from, let's say, a workflow like the Chesapeake Conservancy, where we're extracting the footprints. And then we can take those two data sets and run them through a workflow for actually generating roof forms. And so this is that same data set over the county. This is Fauquier County in Virginia. And I'll just show a few examples where we can actually generate the roof forms based on the classified LiDAR. As well as the building footprints. And then we can easily take this and move it up to ArcGIS Online and share with the entire community. So those are some common workflows of taking different types of data sets and using the out-of-the-box tools within ArcGIS to generate additional products. So I'm going to switch to the web. And I want to show an example of how you can take some of these image services that exist on your portal and start to perform analysis against them within a web environment. And so this is a sample web application, and it's got a variety of different image services in it. I've zoomed to Las Vegas, Nevada, and the image service that you're looking at here is the Landsat 8 service. This is a global service, and it's continuously being updated. And so we have pretty much every image from 2015 to present, with a few filters applied to it just to remove cloudy images. So I'm going to go back to Vegas and just show you some of the analytical tools that you can do with this data. And so first I can bring up a way to change the renders. So right now I have a certain band combination that shows healthy vegetation. So I'm going to hit a drop down and switch to color infrared. We can also apply, because these services are time enabled and we've harvested the metadata, we know the acquisition date for each one of the images. So I can go all the way back to 1975 to look at what Vegas looked like back then. And I can fast forward to 1991, and then I can compare that as I move the slider up to a more recent image. We'll do April 2017, so very current. We can then take those images and then just do a simple visual swipe, so we can compare 1991 to 2017. And then in addition to that, we can apply a mask. So in this case, I'm looking at healthy vegetation. It's automatically computed an NDVI, and then I can move the slider to create a range of what I feel is showing healthy vegetation. And so this is all being computed directly on the fly. So I'm going to zoom to a different area of interest. Okay. And so this is an area in Australia. I'm going to switch back to a different render here. And then I'm going to pick a different date here. And so in this area in Australia, there was recently, earlier this year, sustained some forest fires or some fires here. And so if I want to try to find out or extract that information, I can choose a different index. So in this case, I'm going to choose a burn index. And you can see, just like with the vegetation index, I can now, on the fly, extract those particular pixel values based on that. And if I want to save this, I can click this button and actually save this layer directly to my ArcGIS Online account as a separate layer. So these are some on-the-fly processes that you can do directly on the image. And so while we're here, I'm going to show one other example, in this case with RadarSat. And so I have to log in. All right, so I've loaded my RadarSat image, and I want to perform a little change detection here. And so with my imagery loaded, I can navigate down to this tool. This is called Persistent Change. And first I have to select my image. Bear with me here. Okay, there we go. Okay, so I've selected two different ranges of images. And so what this is doing is an image change detection based on persistent change. So change based on multiple images through time. And so what you're looking at here is in red in this port, an area where there was a ship docked, and then fast forward 4 or 5 images with confirmed change, we can see where that ship once was, and then in blue where some of these ships now occur over here. So this is an example of persistent change and how you can perform some of this directly on the web. So these are just a couple examples of doing change detection and feature extraction within a web browser. So Kurt, I'm going to turn that back over to you.
Awesome. Thanks, Mark. Let me go ahead and share my screen. Okay. Hopefully you can now see my screen, and we're getting close to the end of the session. But before we go and answer some of the questions that have been asked, let's do one final poll type question. So Kathleen, if we can bring up the third poll, and you can see I carefully crafted the question. What is the most appealing part of the ArcGIS imagery platform that you saw today? One of the things, the tight integration with GIS. I guess we didn't show that in too much detail, but considering this is all part of ArcGIS, the two are definitely tightly connected. The new imagery segmentation capabilities that work with high-resolution imagery. You can see some of the land cover results that we got from that 4-band NAIP imagery. The advanced raster analytics with massive distributed processing in the cloud. The easy ability to create and share powerful web apps for image processing tasks, or the use of point clouds for advanced 3D extraction and visualization. So, get your input from the polls. Good. Excellent results. I like to see the advanced raster analytics, and I too am very excited about the 3D point cloud extraction. One of the things that we do encourage, though, is start looking at some of these web apps. They're going to provide a lot more powerful capabilities for you. If you're an image processing expert, don't worry, they're not going to put you out of work. As a matter of fact, they're actually going to enable the hard work that you do and make it accessible to a bigger group of users out there. So, please take advantage and look at those, and Mark and I can help you put those apps together. If you'd like to have more information with regards to the raster analytics and, using the point clouds for feature extraction and other things, Mark and I are also available to help you on those fronts. Now, I did see a few questions come in. Maybe there's been a few more since we last talked. Let me open those up. It looks like the first question from Jason was, you mentioned using an Azure cloud. Is the image server compatible with the Amazon cloud, AWS? And the answer is absolutely. Matter of fact, for us, Amazon kind of came first in our development cycle, and then we moved over to Azure. Lately, we've been doing a lot of work in Azure, and we find the cloud, both between Amazon and Azure, to be equally powerful. And, it's just phenomenal on the types of things that we're going to be able to do. I'm convinced that we're just starting to scratch the surface on being able to do this raster analytics. That distributed processing is extremely powerful. one of the things that we're talking about that I want to share with everybody is, obviously there's an elastic pricing model with spinning up different CPUs in either the Amazon or the Azure cloud. The more you spin up, you just pay for what you're using. Once your processing's done, you spin it back down, and then you're not paying for any of them anymore. It works a little bit different with the Esri pricing model. We have not yet set up elastic pricing model per se for the cloud itself. But if you're an ELA customer, you can take advantage of the fact that you have an ELA and that you can deploy different server capabilities when you need them for the processing that you need to do. Another strategy that we're considering and that you hopefully will be able to provide more information on is a one-time unlimited license purchase, where if you have a big job to do, you get it all set up, ready to run and deploy into the cloud, and as soon as you're sure that it's working and all your data is there, you just get a 24-hour unlimited license, and you kick off a major process and you get the job done in hours instead of days if you're doing big type of work. So we're looking at those types of models to help you implement the various applications in the cloud. And then, of course, we highly, highly recommend, the next question also came from a different Jason, about where is the data being stored. We highly recommend that the data is stored as close as possible to where the processing is being done. So if you're doing processing in the cloud, keep your data in the cloud. The good news is that with that Mosaic data set that I talked about and optimized file format that comes with the Mosaic data set, you are able to leverage S3 storage in Amazon and the regular block storage. Sorry, I forget the name in Azure. But this is the low-cost storage that you can use and store your imagery data. And the CPU then knows where to go, and it uses the Mosaic data set to go out and actually find the pixels that it needs for the processing. So you can take full advantage of low-cost data storage in the cloud for your processing. So definitely the strategy is to keep that data as close as you possibly can to where the processing is in the cloud.
And Kurt, if I could add on to that,
sure.
the process that I just ran in the demo, Jason, the data automatically gets written out to Azure Blob Storage in this case. If it was Amazon, it would be Amazon S3. And so that's just set up as a configuration in part of Portal as to where the data is going to get written out on disk.
Thanks, Mark.
Yeah.
We had another question talking about phonology and metrics and how to handle things like seasonal changes throughout the year, working on time series, those types of things. Esri on staff has a number of image processing experts. Our lead is working on a number of different GP tools that can be used to enable change detection over a time series and do analysis and try to work out persistent change, avoiding the seasonal effects. These are all being developed as GP tools. Some of them are available. I don't have a complete list, but we can get that and provide that for you. But definitely look at GitHub. There's a whole imagery section. Mark, do you remember the name of the imagery site on GitHub?
I don't have that. I don't know it by heart. I can paste it in the chat or provide
or we
that.
Can, yeah, we can post that out in the post information. But on that GitHub site will be a number of tools, including the widgets for the web app builder and some of the GP tools that are being started to build to take advantage of this advanced raster analytics.
Yeah, but it's just Esri.github is our main open repository.
Our main site. And then they can search on imagery from that point?
Yes.
Excellent, excellent. And then there's a question about the Google Cloud. We've talked about the Google Cloud, and there's absolutely nothing from a technology standpoint that keeps us from showing these and moving these exact same tools over to the Google Cloud. And it's something we're considering as an organization to support. And I don't think a decision has been made yet, but I suspect that there really doesn't seem to be a lot of opposition to it within inside of Esri. And so that's going to be potentially another new cloud that we are going to support with our technology. So we are clearly up and working very strongly, very well, both in Amazon and Azure, and I suspect that Google will be the next one that we provide the similar capabilities on. Nothing definite yet, but maybe we'll hear more at the UC. So those are what I saw. Oh, there's one more question that popped in. It's how do the web app widgets require, do the web app widgets require the developer edition? And the answer to that is no. You can get those freely on GitHub, plug them in. It's a little bit of a process to get those new widgets added to the web app library, but we actually have some documentation that help you through those processes, but it's freely available and you can just use the standard web app builder that comes with ArcGIS Online to get those set up.
But they are all available with the developer edition.
Oh, okay. Good
web app builder. Yeah. So all those.
If you do have the developer edition, they are there. Perfect.
But in the future, all those widgets will be part of the configurable apps templates that's part of ArcGIS Online. So you won't have to go outside of ArcGIS Online to generate a similar app as the one I showed in the demo.
Excellent. Thanks, Mark. Well, then one final plug is, I encourage you all to attend the Esri Imagery and Mapping Forum. This is held the Saturday and Sunday before the UC. It's a big event where all the major players who work on imagery and raster analytics inside of Esri attend. We are giving a number of workshops. We have panel discussions. We have papers, all talking about, leveraging the ArcGIS platform for image processing. So I encourage you that if you can get out to the UC a couple days early, join us at the Imagery and Mapping Forum. It's 2 days of real intense look at both, all the raster processing, the 3D processing, and working with all sorts of different content from the various partners that we work with that, share and produce different content for imagery exploitation. So if you can make it, that would be wonderful. You can see the link, goesri.com, IMF 2017, and we look forward to having you out there if you can make it. So Kathleen, that's all I had. Is there anything you want to conclude with?
No, great job, you guys. Really enjoyed the content. Again, this webinar will be recorded, has been recorded, and will be posted online. So we will follow up to everyone who attended with a link if you'd like to view it again or share it with your colleagues. Thank you very much for attending. Thank you to our presenters, and you will be hearing from us soon.